Welcome to Precision Academic World. In today's physics class, we'll be learning equations of motion. Here's our official WhatsApp contact and here's our email address. My name is Mr. Johnson. I will be your instructor for this class. Right here, we have an exercise. Okay, exercise 1 says a body accelerates uniformly from rest at the rate of 3 meter per second squared for 8 seconds. Calculate the distance covered by the body during the acceleration. Okay, if you are a physics student and you feel you are overwhelmed when you approach this kind of question, don't worry. By the end of this lesson, you'll be able to solve this question. So instead of us solving this question right now, we'll have a note. We'll go straight to our notes first. From the note, we'll have equations for uniform acceleration. Okay, the first equation says v equal to u plus at. The second equation says s equal to u plus v all over 2 multiplied by t, that's time. Third equation says s equal to ut plus 1 over 2 at squared, and the fourth equation says v squared equal to u squared plus 2as. Now, you don't need to be confused about these variables. I explained them here. U is the initial velocity of the body, v the final velocity of the body, t time taken by the body during acceleration and during the motion, that's it, and a is acceleration of the body, while s is the distance covered by the body. That's applying to this formula. Now this formula, I don't think you need to cram them. Once you use them 4 times or 3 times, you master them, and that is how I work with formulas, just like I explained on uniform acceleration. Now for deceleration, which is also known as retardation, when the rate of change of velocity moved with time is decreasing. So when it's decreasing, why for uniform acceleration is increasing. When it's decreasing, we'll have negative acceleration, which is same thing as deceleration or retardation. The equation below is used. So you see that everywhere we had positive, we now have what? Negative. So that's just the difference. We'll have negative. And then one more thing I want us to note, for a body from rest, okay, let me just get a highlighter so that I can take notes of that. For a body from rest, the initial velocity is 0. So u is 0 when the body is from rest. For a body at rest, final velocity is 0. So at rest, the final velocity, so that's at rest. So from rest, u is 0, at rest, v is 0. Let's continue. At this very point, you can solve the question. A body accelerates uniformly from rest at the rate of 3 meter per second squared. Take note of this. So have an information here that can help us for 8 seconds. 8 seconds, another information. Calculate the distance. So we are asked to solve for the what? Distance covered by the body during the acceleration. Okay, the first thing you should do is get your formula. So write down your formula. The first one we'll have, the first formula says, this is not retardation, so we'll use uniform acceleration. V equal to u plus at. Remember, v talks about velocity, that is final velocity, u talks about initial velocity, a is acceleration, and t is time. Then we'll have another formula that says s equal to u plus v all over 2 times t, or just t here. The next one says ut plus 1 over 2 at squared, right? The next one says v squared equal to u squared plus 2as. Now you've written your formula down, you need to know which one that will work for you in this question. Okay, from the question you have meter per second squared, that's acceleration. So a acceleration is 3, right? So whenever you see the unit, if you've gone through my videos, you know the units help us to know what we are solving for. And seconds, that's time, 8 seconds. So t is 8, and then we are asked to solve for what? Calculate the distance. And from the formula, s is talking about what? Distance. We don't know s. Now you have a, t, and s, right? They're not telling you anything about velocity. It means that this formula cannot help you. So you're not going to use formula 1 because there is no s in formula 1, and the question is not asking about velocity, but formula 1 has that velocity. Okay, now formula 2 has s, has t as well, don't know if you get, but does not have any relationship with acceleration, which is a. So you're not going to use it. So this is how you know the right formula to use. You have to actually evict them until you see the perfect one. Now formula 3 has u, which you don't need, right? But as well it has t, has s and a. Look at why formula 1 will work. Now a body accelerates uniformly from rest. Whenever we say from rest, it talks about initial velocity being 0, right? Okay, so it talks about initial velocity as 0. Okay, which simply means that initial velocity is going to be 0. So if we should work with this one will make sense. But let's go through this again. V squared equal to u squared plus 2as. This is not going to work. No, it was not going to work. So from here now, we can see that the only one that will work is this. So we have x is equal to ut plus 1 over 2 at squared. Now look at why this formula work, because they say it's from rest, so u is 0, so s is equal to 0 multiplied by t. You get plus 1 over 2 at squared. So you know that anything multiplied by 0 is 0, so that part is gone. So everything about here is 0, so we can just leave it. Now have 1 over 2 at squared. Hope you paid attention and you got what I did. Now from this very point, we are looking for s, right, which is distance, so it makes sense. And now we know that x is equal to 1 over 2 multiplied by a is what from the question? 3 multiplied by t is 8 from the question, and t squared. Please make sure you work with the writing. T squared. Let's continue from this point. So we'll have that s is equal to 1 over 2 multiplied by 3 multiplied by 8 squared is 64, right? So 64. From this very point, I think I want to get my on-screen calculator. Let's see how it goes. Just a moment. We'll have it very soon. Okay, so I think my calculator is ready. From this very point, just multiply directly. 1 times 3 times 64, then you divide by 2. So 1 multiplied by 3 multiplied by 64. Okay, 192. So let's divide by 2. Okay, 96. Okay, so we'll have that x is equal to 96. But remember, in physics, always add your unit, and the unit of distance is what? M, which is what? Meter. And we are done for that very question. Let's go for the next one. Please, if you don't understand, you can pause the video and go through that question again. Okay, now remember the formula we've talked about before. Just a moment. Okay, the second question says a palm fruit dropped to the ground from the top of a tree 45 meters tall. How long does it take to reach the ground? Okay, this how long is talking about time. Now remember from the formula, just write them down before you saw. V equals to u plus 80. That's how I master them. Then another one is x equal to u plus v all over 2, and then t. We'll have x equal to ut plus 1 over 2 at squared, and then we'll have v squared equal to u squared plus 2as. So once you've done this, you can now get to the question. A palm fruit dropped to the ground. Now there's something hidden here. Now because this palm fruit was at a point and dropping to the ground, are you getting me? So it means he moved from rest. Because he's moving from rest, u is equal to 0. I don't know if you get now. So at every point here, we can add u as 0. Okay, and that thing we need to know here is that from the top of a tree 45 meters tall, so it's talking about distance 45. So that meter there is talking about distance. Now how long does it take? How long they're asking you the time, that's time, does it take to reach the ground? So we need to look for a question that has x and t as well. Now this one has final velocity and initial velocity. The initial velocity is not here, but we don't need final velocity for any reason, so this formula is out. This one will help us again, because when we put u as 0 here, we are left with 1 over 2 at squared, and we need x, we need a, we need t and squared. Okay, yes, this g, acceleration due to gravity, they can give you in some questions. So here it was given to us. So anywhere you have meter per second squared, know it's acceleration. So we'll have 10 meter per second squared. They gave us in the question. Always look out for this. So that's another thing you should know. Okay, so this one will have final velocity again, it will not work, and we'll have final velocity here again, so it's not going to work. Okay, at this very point I believe we'll have everything we need, so we use the formula S is equal to ut plus 1 over 2 at squared. But then remember that u is 0, right? So 0 times t plus 1 over 2 at squared. Then from here 0 times t is just 0, right? I'm just taking time so that you don't skip any of the process. So 0 plus anything is that, so there is no need having 0 there, so just have 1 over 2 at and squared. You can now start substituting your values. Okay, at this very point, x, you know what is s? S is 45. Please pay attention. S was given us to us as 45. Then 1 over 2 multiplied by a is what? 10. You can forget about that unit now. And then t is squared, but we don't know what is the t squared. Okay, from this very point we can have that 45 is equal to 1 times 10 is 10. 10 times t squared is still giving us 10t squared. Okay, all over 2. From this very point, when you have such setting in mathematics, you should cross multiply, right? So you need to cross multiply from this very point. Okay, you know what cross multiply literally means, right? So it simply means use what you have here to go this way and then go this way. That's just what it simply means. Okay, now from this point now, 45 multiplied by 2, 45 multiplied by 2, and then we'll have 10t squared. 45 multiplied by 2 should be 90. Okay, we'll have a calculator that can actually help us. So 45 multiplied by 2, okay, we'll have 90. So we'll have 90 is equal to 10t squared. Let's come to this point. Okay, the variable we are solving for, remember, is t squared, right? So when we have 90 is equal to 10t squared, we need to, now t has a coefficient which is 10, right? So you have to divide both sides by the coefficient of t. So I divide both sides by 10. Divide both sides by 10. So 90 divided by 10 is equal to 10t squared divided by 10. Cancel out. So this 0 cancels 0, and then I left with 9. 9 is equal to t squared. Now some persons will make the mistake of stopping here and saying, and actually, you know, leaving the answer as 9, but that's not it, because we have squared, and whenever you have squared in an equation, what do? Take the square root of both sides. So square root of 9 and then square root of t squared. The square root and the t squared will cancel out, and then t will stand alone. So square root of 9 is what? Is 3. So therefore your time becomes what? 3 seconds. Now please don't make the mistake of stopping here. If you do that, you will definitely fail this question. Okay, let's go to the last question. So it's very much simple. Read the question very well, analyze it, and then you solve. Okay, for this question we'll have the motion of an object moving in a straight line is uniformly retarded. So because they said retarded, it means you're going to be using minus. Minus. Okay, so that it comes to rest in 20 seconds after traveling a distance of 40 meters. What is the initial velocity? So they're asking us what for. Okay, let's get our details. First thing is 20 seconds is time, so t is 20 seconds. M, that's distance 40, and then they asked us what is initial velocity is u, right? What is initial velocity? So what are some things we need to solve this question? Let's put in our formula. V equal to u plus at, x equal to u plus v all over 2, and then you have t, and then what again do you have? S equal to ut plus 1 over 2 is at squared. You see, I'm taking time to write them out each time I want to solve. U squared plus 2as. So if you can do this, you will definitely master the formula without cramming it. This is how it works for me personally. Okay, now I am solving for what? Initial velocity, right? So I think virtually all the formula has initial velocity, right? Okay, now let's know the one that will work for us well. So this one, acceleration is not here. They did not give acceleration in this question, so there is no a, not from the question anyway. So this formula cannot work. It has acceleration and does not have distance. Okay, this one has time, has velocity, does not have acceleration. So we need t, s, and u. So it has t, has s, and u. Okay, so I think this formula is somehow going to work, but let's put asterisk, and I'll tell you why. X is equal to, okay, final, then that's not stuff for initial velocity, right? So it's not from rest, so u is not 0 here. Remember, it's not from rest. We'll have acceleration here, cannot work. We also have acceleration here, it cannot work. Okay, so this is the only promising formula. Let's bring it down. So s is equal to u plus v, this is plus v all over 2, and then you have t. Now let's read this question again so I can show you something. The motion of an object moving in a straight line is uniformly retarded so that it comes to rest in 20 comes to rest. Remember, whenever you have comes to rest, what does it tell you? It tells you that what final velocity, which is v. So here v is what 0, comes to rest. What from rest means that u is 0. So in 20 seconds after traveling a distance of 40 meter, what is the initial velocity of the ball? So that's not stuff for u, right? Okay, so because it's retardation, we can say that u minus v. But I think even if you solve with the first one, it doesn't change anything. So at this point, x is equal to okay, the question give us what is x, right? So better I just make start substituting. I want to start substituting directly. So s is what? S is 40. Okay, so u is what? U is the unknown. That's solving for u minus 0. V is 0. And then what is the time? Time is 20, right? 20. So I can just say times, and then all over 2. So from this point, 40 is equal to u minus 0 is just u. Anything subtracting 0 is just that, and then u minus 0, u over 2 times 20. U times 20, that's variable and a number multiplying, just come together. So 20u all over 2. Now we have same thing again. So what do? We cross multiply here. So from this point we have that 40 multiplied by 2 is equal to, every number is divided by over 1, so this times 1 here is same thing, or you can just simply say 20. It doesn't change anything. Okay, from this very point, 40 times 2 is 80 is equal to 20u. So what do we do next? Divide both sides by 20. So let's divide both sides by 20 is equal to 20u. That's initial velocity divided by 20. The 20 here will cancel out, 0 cancel out, right? 8 divided by 2 is 4. That's 2 here is 1, 2 here is 4. So 4 is equal to u. So therefore u is equal to 4 meter per second, right? Remember, the unit for velocity is meter per seconds, right? Don't forget their unit because it helps you a whole lot, and whenever you are solving a question, make sure you write down the unit. Now you see we are done with those questions which you might consider hard. Oh, sorry for that. You might consider those questions hard, and we are done with them. Okay, right now I have a task for you, and I want you to do this task on your own. Now this one says a car starts from rest and moves with a uniform acceleration of 30 meter per second squared. That's acceleration for 20 seconds. Calculate distance covered at the end of the motion. Now remember, when a car is starting from rest, u is 0, right? Then when a car let me say comes to rest, v is 0, and that's it. So we are done. Very much simple. Oh, thank you so much for watching. Like, comment, and subscribe to get our updates. Thank you so much.